Hey, what's up guys? My name's Aiden and welcome to Group Force Design and Make project video. Before we dive into this video, let me introduce the team. We have Gareth, Rohan, Songzi, and me. We met during our first tutorial where we were told to make a robot which could do all this. Thankfully, we were given some instructions to a template project. Assembling that felt like we're making the Lego Death Star, and this was our Death Star. This was basically the starting point for our project. As a result, this robot was kinda useless. I mean, are those cardboard wheels? But in all seriousness, this template project did basically teach us how to use everything and got us on a great start. With this newfound knowledge, we revamped this into this. Let me show you how we got there. Now the first thing that got to go were the wheels. After some thought, we ended up with these laser printed epic acrylic wheels as our final design. You see, the robot had to go over a 3cm bump, so we just made the wheels bigger, so that the bump in comparison got smaller. Now, the robot also had to climb a ramp, and we had figured out that by adding bumps of hot glue to the wheels, they could gain more traction. So we just applied that concept over and over again, adding bumps to the wheels itself and gluing strips of anti-slip mat material around the wheels. Our robot also needed some lumbar support so that it wouldn't just drag on the floor when it moved, so we just added a wheel to the back. Now you might be saying, actually, that's 2 wheels? Well, yeah, it needed to be more stable, so we made it 2. But you see, we wanted our robot to be the lightest for that one juicy mark. These 2 wheels could be controlled by one motor, so it's basically acting as one fat wheel. A lot of other teams had 2 skinny wheels powered by 2 different motors at the back. This design gave us a weight advantage over them and also required less power. As you may have noticed, we had given our robot a total makeover using ice cream sticks. They were light and easy to work with, and just by spamming them with hot glue, we could end up with this, a solid framework that held everything in place. As for our circuit, we had a similar setup going as the template project. An Arduino powered by a 9V battery that could detect obstacles with an ultrasonic sensor and control the speed and direction of the motors via a H-bridge motor driver. Our robot also had to move until it detected a wall, stopping and edging it by at most 5cm. So the Arduino was coded to stop the motors if the sensor detected an obstacle which was less than 10cm away. This stopping distance was something we derived from lots of trial and error. To get the ball rolling, or rather, throwing, we had a makeshift ice cream stick arm that was controlled by a servo motor, acting as a catapult. We coded it to only throw the ball after it detected a wall, and to prevent it from confusing it with the ramp, just angle the sensor. We actually struggled a lot with this. We could get the ball flying, but not just over the wall. Our robot had to be less than 30cm, so we couldn't just extend the arm. Eventually, we figured out that if we just stuck the catapult way up this cardboard thing and shortened its arm, it would work. We did think of other methods to launch the ball, like using some contraption that involved rubber bands, but we also didn't want to overcomplicate things, so we just stuck with this method. Now, our robot was almost ready. We only had to switch connections around the H-bridge and add code that reversed the robot after it flung the ball. That did not work out so well for us and we only had a day left. But thanks to Songzi and Rohan's Sunday efforts, we did not have to say goodbye to that one juicy mark as they figured out that there was an issue with the electrical connections and fixed it just by shifting the motor driver up the breadboard. With our robot finally working, it was time for the graded run. Our robot was functioning pretty consistently, so what could go wrong? We decided to go for an early graded run, but our catapult did not catapult. After fixing that issue, we tested the robot and realized it was getting stuck on the ramp. So we cleared space under the robot, moving the 6V battery pack to directly under the Arduino. We could do this because we were not using those batteries, but they still had to be there. After some successful test runs, we went for another graded run, which scored 2 points. It kinda just died on the ramp. Trying to fix this, we replaced the sensor, but that didn't work. Finally, we decided to just move the sensor way up that cardboard thingy. And that solved the issue. We only had 1 attempt left, so that meant it was time for our robot to go to fat camp. During this incredible weight loss journey, our robot lost its battery holder. As for those batteries, we just raw dogged them on the breadboard, on the ice cream stick, wherever possible. We went for our last attempt, and it was perfect. Although slow, it did get the job done. We were also the second lightest at 460 grams, losing to another team by less than 2 grams. One thing obvious from other teams' graded runs, our robot was a lot slower than the others, but that's because we didn't have to use the AA batteries, since we only had 3 motors. This was definitely a genius move by the team to make our robot lighter, but in practical applications where speed is rather important, this probably isn't the best strategy to rely on. A lot of other teams also used a lot more sheet material in their design, unlike the ice cream grandma robot we had just made. I think it was better this way as ice cream sticks are cheap, recyclable, light, wood, sturdy, and convenient. Like, if we wanted to route more wires to the robot, or add more components that do different things, it would be easy to do so, and we can do it all while saving the earth. Before I end this video, I want to give a special thanks to the team. Having each other allows us to focus on different parts of the project at the same time, which was much needed when it came to balancing out the crazy schedules we all have. The different inputs and skill sets we each provided also enabled us to fix the many problems which came when making the robot. We certainly would not be able to make this masterpiece without everyone. Anyways, I hope you guys enjoyed the video and found it educating or entertaining. Either ways, that's it from me. Thank you for watching. Please like and subscribe.